Hello everyone, in this video I'm going to present to you my CS50 Cybersecurity final project, the Rapid Reset. First of all, my name is Salam Ali Salam Abdulaziz. I'm 18 years old and I am from Yemen. I currently study computer science engineering at the University of Debrecen in Hungary. My EDX username is Salam_0010. My GitHub username is Salome0010. This video is being recorded on the 23rd of January 2024. So why the rapid reset? Well, there are a couple of reasons. First, it is a pretty dangerous vulnerability, as it has been designated a high severity vulnerability with a CVSS score of 7.5 out of 10. The second reason, that it had big effects on big companies like Google, Cloudflare, and Amazon. Third, it is related to the web and HTTP, and I'm pretty much interested about the web and I'm willing to learn a lot about it. And I definitely learned a lot while researching for this project. Lastly, it is related to some of the topics discussed in this course, especially the denial of service. So now I will introduce the vulnerability briefly, and then we will dive on details about the effects it had and how it works. So, HTTP2, the Rapid Reset vulnerability. Google, Cloudflare, and Amazon Web Services and others recently disclosed a vulnerability in HTTP2 protocol, which is being tracked as CVE 2023-44487, which is now popular as the Rapid Reset. The flaw lies in how the HTTP2 protocol was implemented to increase the efficiency of transmitting various messages between endpoints by using the stream multiplexing feature. The vulnerability allows a remote, unauthenticated attacker to cause an increase in CPU usage in the server that can lead to a denial of service. The vulnerability was exploited in the wild from August through October in 2023. Alright, so now we can discuss the effects of the vulnerability. So starting on August the 25th in 2023, Cloudflare started to notice some unusually big HTTP attacks. These attacks were detected and mitigated by their automated denial of service system. It was not long, however, before they started to reach record-breaking sizes and eventually peaked just above 201 million requests per second. This was nearly 3 times bigger than their previous biggest attack on record. Google also mitigated this type of attack and has recently stated that this new series of distributed denial of service attacks reached a peak of 398 million requests per second, breaking a new record by being 7.5 times larger than the previously largest denial of service attack that Google has blocked. And as you can see here in this image from Google, as it shows the scale of the attack that only lasted for 2 minutes. So now let's talk about how this vulnerability works. So basically, HTTP2 uses streams to transmit various messages or frames between the endpoints. Stream multiplexing is the core feature of HTTP2, which allows higher utilization of each TCP connection. Streams are multiplexed in a way that can be tracked by both sides of the connection with only using one layer 4 connection. Stream multiplexing enables clients to have multiple in-flight requests without managing multiple individual connections. The number of concurrent streams can be controlled by the server, but usually it is about 100 streams per connection. The HTTP2 protocol also allows client to indicate to the server that a previous stream should be cancelled by sending a reset or an RST stream frame. The protocol does not require the client and the server to coordinate the cancellation in any way. The client may do it unilaterally. The client may also assume that the cancellation will take effect immediately when the server receives the RST stream frame, before any other data from the TCP connection is processed. This attack is called the Rapid Reset because it relies on the ability for an endpoint to send a reset or an RST stream frame immediately after sending a request frame, which makes the other endpoint start working and then rapidly resets the request. The request is cancelled but leaves the HTTP2 connection open. So here's an image from Google Cloud that shows various HTTP attacks. On the left, we have a typical HTTP 1.1 attack. In this version of HTTP, there's no stream multiplexing, so you only send a request and then receive a response and then send another request one at a time. In the middle, we have a standard HTTP2 attack. Here you can see the stream multiplexing. We are sending multiple requests at a time and we are receiving their response. So a typical HTTP2 attack would be just sending requests and receiving response and then sending a lot of requests again and so on. However, in the rapid reset attack, as you can see here, the client sends a request and then immediately sends a cancellation, a request and a cancellation, a request and a cancellation. By doing this, the client can send over 100 requests in the same connection because it is canceling every request it has sent just after the server started to process it. And this can overburden the server and will lead to a denial of service. So what to do about this vulnerability? Well, any enterprise or individual that is serving an HTTP-based workload to the internet may be at risk from this attack. So anyone that uses HTTP2 is at risk. So what to do here? Well, unfortunately, there's not much to do. This is not like a virus or a malware that we can detect. The problem here is that the vulnerability is in and of itself a feature of HTTP2. So a straightforward solution might be to upgrade to HTTP3, as HTTP3 does not have this feature. Another way to solve this problem is by closing connections after deciding that they are malicious, using the built-in go-away frames. So closing connections is easy, but the difficult part is to decide which connections are abusive and which are not. One way of doing this, as Google stated, deciding which connections are abusive and which are not, centers around tracking connection statistics. For example, if a connection has more than 100 requests with more than 50% of the given requests cancelled, then this could be a candidate for a mitigation response. Like, as I said, by closing the connection and also by blocking the IP address of the device that was sending those requests. Here we can find the reference list and the resources of this project. So this is the end of my presentation. I hope you like it. I would like to thank all the staff behind CS50 for their great efforts and their great work. I really enjoyed this course and I'm looking forward for your future courses. So that's it. I'm looking forward to hearing from you soon about my project, and thank you for watching.